The South Pole is more than penguins and endless snow. There's a hidden ghost world within it. Look, it's right here on the globe. Don't confuse Antarctica with the Arctic, which is at the top of our maps. Much smaller in size, and, let's face it, way less mysterious. The ice sheet covering Antarctica is about 1 to 3 miles thick, which is up to 16 Eiffel Towers stacked on each other. This massive blanket hides the true features and contours of Antarctica's land. We still don't know much about this mysterious continent, and it is ice and snow that are to blame. We still don't even know the true shape and size of this continent. Mapping Antarctica without some huge shovels is an incredibly hard task. But satellites learned to penetrate the ice with their cameras. And now we know there's actually an enormous, dramatic ancient landscape beneath the snow. The ghost of the past. About 90 million years ago, Antarctica was a much warmer place. It was actually a lush rainforest with tons of plants and probably teeming with life. It even had rivers flowing through it. Then the ice came. This happened about 34 million years ago, during the transition from the Eocene to the Oligocene, when our planet cooled significantly. It was the beginning of one of our several ice ages. The land remained, but now was hidden under ice and snow that got thicker and thicker. To a regular eye, Antarctica turned into a white desert, vast, flat, and featureless. Time went on. This massive ice sheet moved around, smoothing and shifting the ground beneath it. Over the millions of years, it changed what the land looked like. Now, if we looked under the ice, it wouldn't hold any signs of the original South Pole, except for one place. In areas where the ice is especially thick and doesn't move much, like in East Antarctica, it has actually worked the other way around. It became like a super thick blanket that protects the land. Normally, things like wind or rain slowly wear away the ground over time, changing its shape. But since we have this protective ice blanket, it prevents these natural processes from reaching the stuff underneath. So, the ground stayed almost the same for millions of years, like it's been frozen in time. This special area near the Aurora and Schmidt subglacial basins has become the ghost of Antarctica's landscape. This place was barely touched even since it was first covered in snow 34 million years ago. This is a historical footprint, a place that can tell us what Antarctica's ground looked like before it became a freezing nightmare. As scientists peered under East Antarctica, they saw an amazing ghost. The traces of the rivers that were flowing there millions of years ago, various valleys, and some weird little islands, as well as 3 big chunks of land shaped like the letter U. Hey, what's that all about? You see, the continents on our planet are moving constantly, sliding along the red-hot lava mantle like cereal on milk. Over history, they came together and broke apart several times. Hundreds of millions of years ago, several continents were a part of one enormous Gondwana. Antarctica was one of them. It used to be one huge landmass. But when Gondwana broke apart, the poor continent got stretched by tectonic forces. Parts of land were pulled away from each other. Whoosh! And they got torn apart. And that's how we got these big chunks or blocks of land under thick layers of ice. In any case, scientists now want to explore this ghost a bit more. But to study it deeply, they need to actually drill down through the ice, like using a straw to get to the bottom of a thick shake. This will help them pick up some rocks and dirt from way below to learn more about the Earth's history and climate. Antarctica is the 5th largest continent in the world, approximately bigger than the entirety of Europe or Australia, competing with the entire South America in size. Aside from East Antarctica, we discussed there are several more regions: Antarctica Peninsula, South Pole, West Antarctica, and the Ross Sea. The continent is basically a frozen sandbox, and all its hidden, mysterious landscape is actually less explored than Mars's terrain. We only know for sure that without ice, it wouldn't just be flat and empty, but an entire world full of big mountains, huge canyons, and even fiery volcanoes. Some of these volcanoes are so huge that they peak above the layers of snow. In West Antarctica alone, there are at least 138 volcanoes, though only about 8 or 9 are active today. One of the craziest ones is Mount Erebus, the southernmost volcano and the tallest one on the continent, about 12,500 feet high. And deep beneath the ice sheet, this guy hosts incredible, beautiful subvolcanic caves. The temperatures there are warm enough for t-shirts. The Antarctic Peninsula, or Lesser Antarctica, looks like a bunch of mountainous islands deeply underground. It has newer volcanic rocks that are part of the Pacific Ring of Fire, which is like a giant circle of volcanoes and earthquake zones around the Pacific Ocean. The Greater Antarctica is a huge part, almost as big as Australia. It consists of East Antarctica and the South Pole. Beneath the ice, it's a place of rocks that have been around for a very, very long time, including the special zone we mentioned. You probably know that Antarctica is nearly devoid of humans. No wonder, with a mean temperature of about -46 degrees Fahrenheit. But even though this place is horrifyingly cold and deserted, life still clings on. You guessed it, in the underworld. In 2017, scientists found DNA traces of algae, moss, and even possibly unknown small animals in the deep caves. That means that even in such crazy conditions, there are still unique ecosystems thriving in little isolated warm pockets beneath the snow. There was another incredible find beneath Antarctica's Ross Ice Shelf, a lively ecosystem vibing within an underground river. Scientists have long suspected that Antarctica's underworld should have some freshwater lakes and rivers. One day, a satellite spotted a groove there. They decided to explore it and used a hot water drill to melt their way through the ice. As they reached the underworld, they dropped a camera into one of those hidden fresh rivers. And at first, they thought they'd find just some rocks or something. But instead, they stumbled upon hundreds of amphipods, tiny shrimp-like creatures. Little ones instantly swarmed around the lens. Shrimps blocked the camera and scientists couldn't check out what they wanted to. Pretty funny, but at least that means that there really is an important ecosystem deep within Antarctica. Now, they're gonna explore it. And all this is just the beginning of the mysterious underworld. Antarctica's snow also hides the deepest canyon on Earth under the Denman Glacier. Well, Mariana Trench is still the deepest point on Earth, but it's a part of the oceanic crust, geologically speaking. Also, in 1958, explorers found a huge mountain range under the ice, as big and tall as the famous Alps Mountains. The range stretched for about 745 miles with peaks as high as 1.7 miles. And all this magnificence is buried under tons of ice. Who knows what else we might find there? Antarctica holds about 60% of our entire planet's freshwater, which means it would be pretty bad if it melted. For example, there's this Doomsday Glacier, officially known as Thwaites Glacier. It's a huge ice formation, about the size of Florida, and it's melting right now. Every year, the sea levels rise by 4% because of it. If this guy melts away completely, the sea levels all around the world will increase by 2 feet, which might not sound like a lot, but it would be catastrophic for coastal areas. Luckily, researchers have found that even if its ice shelf were to collapse in the next 50 years, the glacier itself wouldn't retreat as quickly as they feared. It's still losing ice rapidly, but it would be quite a slow process. Look at those lush coniferous forests and tundra. What a wonderland! You may have mistakenly thought it's Canada, but it's not. It's Antarctica, about 34 million years ago. So what makes Antarctica this frigid today? It turns out a mix of dropping carbon dioxide levels and some tectonic shuffle played a huge role in transforming this ice-free paradise into the frozen continent we know now. About 50 million years ago, CO2 concentrations were sky high, strutting around at around 1,000 to 2,000 parts per million. But as those levels tumbled down, global temps started to drop, paving the way for the mighty ice sheets that later took over Antarctica. While the CO2 dive was happening, tectonic activity was also working its magic. The big split between South America and Antarctica opened up the Drake Passage, which created the Antarctic Circumpolar Current. This powerful current acted like a bouncer, keeping warm air and ocean currents from crashing the Antarctic party, and helping keep things rather frosty. If you mix up Australia and Antarctica, you're not that wrong. These two continents used to be one. If you mix up Austria and Australia, it's much worse. By the way, don't fall for the internet myths and memes. There's no help desk in Austria specifically for people who intended to fly to Australia. Now, look at this magnificent Australian pink beach. It's precious, and not in a figurative sense. Those mysterious pinkish sands are actually garnet, and it's widely used in jewelry. Geologists studied those sands and came to the conclusion that the garnet contained there is older than local mountains. That doesn't make sense, right? In fact, it does. You see, Australia didn't used to be this very detached continent as it is now. Many millions of years ago, Australia and Antarctica were part of the supercontinent Gondwana, and glacial erosion released the garnet, which eventually made its way to the beach. These sands formed when South Australia was flat and chill, long before the mountains appeared. Most garnet gets washed away, but this batch has a rich history, tracing back to glacial rocks in the Transantarctic Mountains. So this pink sand comes from an ancient mountain range hidden under Antarctic ice. Not only does Antarctica ice hide gems like garnet, if you look harder, you might find entire buildings. Sounds insane, but this is exactly what a British explorer did. His name is Chris Brown, and he uncovered an entire building beneath the ice. He was traveling to the pole of inaccessibility, and it all started with a bummer. Chris and his son had their plane broken. Suddenly, they spotted a lone bust peeking out of the snow. This place was an old meteorological station. Despite freezing conditions, Chris and his son Micah had a blast exploring. Chris is on a mission to conquer all 7 earthbound poles of inaccessibility and has tackled 5 so far. I guess you already know that Antarctica is the largest desert on Earth, much larger than the Sahara or the Gobi. Still, despite being the driest continent on Earth, it boasts a seriously weird waterfall. Nestled in the mesmerizing McMurdo Dry Valleys, it's 5 stories tall and looks like it's gushing blood. It's even called Blood Falls. It may look outlandish and even frightening, but its nature can be easily explained. The water that creates this crimson cascade was once a salty lake, but over time, it became sealed off from the outside world when glaciers formed on top of it. Now, this ancient water hanging out 1,300 feet below the surface has cranked up its salt levels to 3 times saltier than the ocean. This salt water is also loaded with iron and gets 0 oxygen or sunlight. When the iron-rich water trickles through a crack in the glacier and meets the air, it rusts up, turning dark red. You may have mistakenly heard that no bug species belongs to Antarctica, but it's not exactly true, because there's this tiny Antarctic midge living there. Plus, there are some spiders too. Those aren't your average spiders hanging out in the darkest corners of your apartment. Those are critters lurking in the chilly darkness of the Antarctic ocean floor. These little marine creepers are actually arthropods and can stretch around 20 inches across. As if that wasn't bizarre enough, they also breathe through little holes in their legs. Quick question. What's the color that you associate most with Antarctica? I'm sure it's white. That's my association too. However, Antarctica may look like a slice of watermelon. That colorful snow comes courtesy of a tough little algae called Chlamydomonas nivalis. When things start to warm up during the Antarctic summer, these little guys release their vibrant red and green spores, painting the snow in wild and funky colors. But it's best to steer clear because that snow is not just a pretty sight. It's also toxic and definitely not edible. Searching for fossils is always a blast, but when you're in one of the most remote spots on the planet, it gets even more exciting. A diverse team of scientists recently hit the mother lode, pulling in over a ton of fossils from ancient marine life, dinosaurs, and birds from the late Cretaceous period, about 71 million years ago. Their adventure kicked off with a flight to South America, followed by a 5-day trek through the infamous Drake Passage. Upon reaching Antarctica, they set up camp using helicopters and inflatable boats. You might be thinking, why dig in Antarctica with all that ice? Well, it turns out there are places where rocks pop up, depending on the season. The team went to James Ross Island, located in the Antarctic Peninsula, and they went there during February and March. And that's one of the few parts of Antarctica where in summer, rocks are exposed, and those rocks can come from the age of dinosaurs. The expedition was a success, as they discovered over a ton of remarkable finds. Next up, the fossils will head to Chile before making their way to Pittsburgh's Carnegie Museum of Natural History. Among their discoveries, they found relics dating back about 71 million years, alongside some around 67 million years old, including plenty of snails, clams, and various marine creatures. Yikes! Look at this creepy sea worm. It could live in LA and be a star in a horror movie, but it chooses to call the chilly waters of the Southern Ocean near Antarctica its home. These worms can grow up to 8 inches long and 4 inches wide, but don't let their spooky exterior trick you. Research suggests they might actually be superheroes in disguise, playing a vital role in keeping ecosystems buzzing. Now, see that head? It's not really a head, it's just a retractable throat that helps this toothy creature chow down on its meals. Antarctica has many creepy critters to offer. Let me introduce you to the Antarctic strawberry feather star. It's not like Patrick from SpongeBob though. It's more like a deep-sea creature straight out of a horror movie. Picture this, 20 wiggly arms, some stretching up to 8 inches, all decked out with these bizarre little bumps. Yikes indeed. Back in 2014, scientists buried 34 seismic monitors in the snow on the Ross Ice Shelf, which is huge. Think of it as an ice slab the size of Texas, just chilling over the Southern Ocean. These clever little machines picked up a nearly non-stop buzzing. Even though our human ears usually can't catch these low-frequency sounds, scientists have worked their magic and made them audible for us. They even shared the creepy audio online. A glaciologist from the University of Chicago says that if you could hear this vibration, it'd sound like a swarm of cicadas taking over the backyard in late summer. But these glacier explorers weren't trying to capture spooky tunes. They're actually on a mission to monitor the Ross Ice Shelf because things are heating up, literally, and the ice is melting faster than ice cream on a hot day. Ice shelves are like Earth's safety plugs, keeping all that massive ice from surging into the ocean. So what exactly is making all that noise? It's likely just strong winds whipping across ice dunes, creating a kind of natural vibration. Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right, but there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gamburtsev Subglacial Mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet. We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gamburtsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red-hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary scale destruction? If the Gamburtsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons, but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device. a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gamburtsev Mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, the Gamburtsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gamburtsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting, but there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world, build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there. Scientists punched through more than 1,600 feet of ice and finally solved the billion-year-old Antarctica's magnetic mystery. Their find also completely changes our understanding of how continents collided and merged around the same time. But first things first. Several decades ago, scientists were running geophysical surveys in Antarctica and noticed stripes of magnetic highs and lows, areas where the crust magnetizes differently than everything around it. Nobody could figure out the cause. Researchers started mapping those magnetic anomalies in the early 1960s. Back then, they used airborne magnetic surveys that flew lines across the ice to detect unusual magnetic signals. They linked those magnetic anomalies to volcanic rocks hidden beneath the ice sheet. By the mid-1990s, international scientists launched an entire project to map Antarctica's magnetic anomalies across the entire continent. They put together millions of miles of magnetic survey data from airborne lines, sea, and even observations from space, and managed to produce the first continent-wide magnetic anomaly maps by the end of the 1990s. Those maps show how Antarctica's crust formed and changed through time. So they knew what was going on there, but couldn't explain why it happened like that. To get answers, researchers from St. Petersburg State University teamed up with scientists around the world to study one of the hardest places to work on the planet. Antarctica sits smack on the coldest winds on Earth, with ice sheets of about 1.5 miles thick on average. And that ice doesn't just sit there. Over millions of years, it grinds rock, buries valleys, and hides everything beneath its fractured frozen blanket. To reach the ancient bedrock that held the magnetic mystery, researchers had to drill over 1,700 feet of ice before they could even pull up samples from the underlying crust. When they brought those rock samples back to the lab, they turned out to be pieces of ancient volcanic island arc. There were entire chains of volcanoes that formed above subduction zones, similar to the Aleutian Islands in Alaska or the island arcs near Japan. In the lab, scientists looked at chemistry, measured magnetic minerals under microscopes, and used radiometric dating. This method reads the decay of unstable atoms to figure out the age of an object. And all this helped them determine that these rocks had a completely different origin than typical Antarctic crust. The team found that this volcanic island arc didn't just drift nearby. It collided with East Antarctica when the supercontinent Rodinia was in the forming stage. Rodinia gathered nearly all of Earth's landmasses into one colossal formation, and when that volcanic arc crashed into East Antarctica, it welded into place like two tectonic puzzle pieces, locking together. That collision left behind a distinctive magnetic signature, one that satellites can still detect today. The way these rocks recorded magnetism makes perfect sense once you understand a little bit about magnetic minerals. When molten rock cools, iron-rich minerals like magnetite align themselves with Earth's magnetic field, pretty much like tiny compass needles freezing in place. Over geological time, these locked-in magnetic directions act like memory sticks. When scientists studied the Antarctic samples, they found magnetic directions that didn't line up with ancient Antarctica's old magnetic field, but did line up with where that volcanic arc would have been long ago. That magnetic memory showed that the rocks didn't grow in place, but traveled and slammed into Antarctica. Alongside magnetic clues, scientists also compared gravity measurements from satellites and ground surveys, and found even more evidence that the rocks beneath East Antarctica weren't ordinary. Some regions of Antarctica have slightly weaker or stronger gravity depending on the density of rocks buried beneath the ice. Denser rock, like ancient volcanic crust, produces a slightly stronger gravitational pull. If you picture lying on a mattress, the way it dips over a bowling ball differs from where there's only foam. That's how gravity variations tell scientists something unusual lurks below. Those gravity patterns matched where the weird magnetic rocks were coming from. It only backed up the idea of an exotic chunk of crust attached to Antarctica's edge. And these findings show us that Rodinia's formation wasn't tidy or orderly. Bits of crust from far-off places got plastered onto Antarctica's edge and became clues that waited a billion years for scientists to dig them up. Over time, heat, pressure, and tectonic forces buried and reshaped those rocks, but their magnetic fingerprints survived. Another Antarctic mystery scientists recently solved is the secret of Blood Falls. Yep, as the name suggests, it's blood-red water pouring out of a glacier, and no one could explain what gives it its color. Back in September 2018, a camera captured the falls suddenly coming alive. At almost the same moment, instruments sitting on top of the glacier recorded something odd. The ice surface actually dropped slightly. The glacier sank, the red water flowed, and then the ice slowly lifted back up again weeks later. So beneath all that heavy ice, there is salty water locked away for ages. The glacier presses down constantly, squeezing that hidden water harder and harder. When the pressure builds too much, the ice shifts, opens somewhere deep below, and the trapped liquid rushes out in a sudden pulse. Blood Falls acts like a pressure valve for the glacier. Salt turns the water into a thick brine that refuses to freeze, even in Antarctica's brutal cold. Over thousands, maybe millions of years, freezing concentrated the salt more and more. It left behind a liquid that can still move through solid ice. Scientists believe minerals from buried rocks feed that salty mix and give us clues about what lies far below the glacier. The red color makes the whole scene look dramatic, but the explanation for it is surprisingly simple. Underground, the water carries dissolved iron. The moment that liquid touches air, the iron reacts with oxygen and turns rust red, just like metal left out in the rain. Within minutes, bright crimson stains spread across the white ice. Cameras near the falls showed fresh red staining spreading day by day. At the same time, temperature sensors deep in the lake where it flows recorded sudden cooling. Dense brine had slipped into the lake underwater and disturbed layers that normally stay perfectly stable. Even small disruptions matter here, since life survives in narrow zones where nutrients barely exist. As the drainage continued, scientists noticed the glacier slowed down too. With less water acting as lubrication underneath, the ice pressed harder against the rock below and moved forward more slowly. All this means that hidden water controls how fast entire glaciers slide across Antarctica. Some observations from the air also showed salty groundwater pathways stretching miles beneath the valley floor. The brine doesn't just sit under the glacier, but travels through rock and ice before finally escaping at Blood Falls. And deep inside that dark, oxygen-free water, there's life. Microbes live off iron and sulfur instead of oxygen and thrive in total darkness for millions of years. This ancient liquid may have stayed sealed beneath the ice long before humans even existed. Lake Enigma is another cool discovery from Antarctica with a twist. For a long time, researchers thought it was completely frozen solid. But during one expedition, they found that under the thick ice, there was a layer of liquid water about 40 feet deep. To learn more, they drilled through the ice and sent down a camera to explore what was hiding in the lake's depths. The lake's water, which they think comes from the nearby amorphous glacier, through a secret underground pathway, was filled with strange microbial life. These tiny microbes lived in mats that covered the lake bed. Some of the mats were thin and spiky, and others looked like crumpled carpets or even small tree-like shapes that grew up to 16 inches. Many of the microbes could make their own food through photosynthesis, just like plants do, and gave the lake a high amount of oxygen. One of the coolest discoveries was a type of microbe which usually lives in low oxygen places. Lake Enigma might be similar to environments on icy moons like Europa or Enceladus. So it could mean that these moons also have hidden water under their ice and possibly microbial life too. A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events, like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever Anita has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wiesel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas like maybe it's some new kind of physics or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.